Hey guys, it's off1 here, and today we're going to be solving insert interval. In this problem, we're given an array of non-overlapping intervals, where each interval tells us a start point and an end point, and they're telling us that it's sorted by ascending order already, and we're also given a new interval that represents a start point and an end point, and what they want us to do with this is insert it into the list so that it's still sorted in ascending order, and so there's no overlapping intervals. And if there is an overlapping interval, we're supposed to merge them. And in the end, they want us to return the new intervals list. So here I've drawn this example down here. And as you can see, the intervals are 1 and 3 and 6 and 9, which I've drawn. And we're given a new interval that they want us to merge, that is 2 and 5. And as you can see, the 2 is overlapping with this first interval. So in the end, they want us to make this 1 and 3 and 2 and 5 interval into one big interval that goes from 1 all the way to 5, like this. And in the end, we would return this new interval where we only have 1 and 5 and 6 and 9. So here I've written out another example, and before trying to solve this problem, let's just think about the scenarios that can come up from our new interval being inserted into the list. So that's pretty easy. Either 1, they overlap, or 2, they don't overlap. Okay, well that was pretty obvious. But let's try and think about what this overlap really means here. So for example, let's just say we have this interval here, and our new interval is like this. And let's just say this is 3 and 5, and this is 4 and 8. So how do we merge these? Well, we know that the final outcome should be an interval that is from 3 to 8, because this would include both of the intervals. So when we find overlapping intervals, we can say that the new interval is going to be equal to the minimum between the two start times. So in this scenario, 3 is less than 4, so that would be our new start time. And the end would be the max between 5 and 8, because we need to include the greater number. So the max between 5 and 8 would be 8, and this would be our new interval. So, when merging overlapping intervals, we want to take the minimum of the two start times for the beginning point and the max of the two end times for the end point. So now that we understand how to merge the intervals if they're overlapping, let's try and solve this example. So here I've drawn the intervals on this number line here, and our new interval is above them so we can see where it's supposed to be inserted. And this orange line here represents our new interval list, which is going to have our new interval merged into it without any overlap. To start, we're going to have to compare every interval in our list to our new interval to see if there's any overlap. So we're going to start with our first interval here, 1 and 2, and we're going to compare that to 4 and 8 to see if there's any overlap. And the way we know there's overlap is if the start of the new interval is less than the end of the interval we're currently looking at. But as you can see here, that is not the case. These two are not overlapping. So what we're going to do is just insert our current interval to our new interval list here. So I've inserted the interval, and I've also named this result just so it's a little clearer that this is the result array. So now we're going to check our next interval, which is 3 and 5. So let's see, is the start of our new interval less than the end of our current interval? Yes, and that means there's an overlap. And when there's an overlap, we want to merge the two intervals together so that there's no overlap. So if you remember, to merge the two intervals, our start point is going to be the minimum between 3 and 4, and the maximum between 5 and 8. So the minimum between 3 and 4 would be 3. So now our new interval is going to be 3 all the way to 8, because that is the max between 5 and 8. And we don't want to insert this just yet, because there could be more overlap with the other intervals, and we can already see that's the case here. So now let's look at our next interval, which is going to be 6 and 7. So let's see, is the start of our new interval less than the end of the current interval? Yes, so that means there's overlap. And to take care of this overlap, we're going to take the min between the new interval and the current interval, and then just make that our new start, and then take the max between 7 and 8 and make that our end time. But as we can see here, the new interval engulfs this current interval, so we don't need to update anything here. But because we technically merged these two intervals, we still don't want to insert this new interval into our number line, because there could still be more overlap in the future. And then only then, when all the overlap is resolved, then we insert this. So now we go to our next interval, which is 8 and 10. And one thing I forgot to mention is that if the points are in the same point, so let's say these 8s, these are technically considered overlapping. And same thing goes for this 3 here. This 3 here would be considered overlapping because they are at the same point. So this interval here and this interval here are considered overlapping because they meet at the same point. So now we just update our new interval to be the minimum between the two start times and the max between the two end times. So as you can see, the minimum is still going to be 3, but the max now is going to be 10. So our new interval is going to be updated to 3, 10. And because we merged these two intervals, we still don't want to insert this to our result array because there could be more overlap. So now we look at our last interval here, 12, 16. So is there any overlap? No. As we can see here, 3 and 10 is not in 12, 16. so we can finally insert our new interval into our number line. And then now that we're done going through our intervals list, we can insert this 1216 because we know there's no other intervals. And now we're done. This would be our final result array. So now let's go over the time and space complexity. Our time complexity is going to be O of n, where n is the number of intervals we have because we have to iterate through all of them. For space, we're going to do the same thing, O of n, because we need to store our intervals. And I'm pretty sure this can be done in constant space, but it would be a more complicated solution that I don't think an interviewer would expect you to come up with. So now let's get into the code. To start, I'm going to initialize an empty array, and this is where we're going to store our new intervals list. And then from here, we just want to iterate through every interval. So for interval in intervals, and now we have to do 3 checks. So our first check is going to be if our new interval is less than our current interval. The other scenario can be our new interval is greater than our current interval. And if those 2 cases aren't true, then that means there's an overlap. So for this first scenario here, let's make up an example. Let's say our new interval is going to be 3 and 5, and our current interval is 6 and 8. Well, if that's the case, then that means the new interval is never going to have any overlap with any future intervals. So we could just append our new interval to our result, and then just keep appending the rest of the intervals list. So first we check if our new interval at the end is less than our current interval at the start, then that means the current interval is greater than a new interval. And if that's the case, we said we would append the new interval, and then we want to just append the rest of the list to this result array now. And there's multiple ways to do this, but I'm just going to say our new interval is not going to be equal to our current interval, and then this should never produce any errors because we're already guaranteed that the intervals list has no overlap. So this would just keep iterating until the very end, and then our result array would have every single interval. And now we're done with that scenario. So now we check if our new interval is greater than our current interval. And to do that, we have to check if our new interval at the start is greater than our current interval at the end. And if this is true, then that means the new interval is greater than the current interval. So there's no overlap there. So we can just add our current interval to our result list. And this should be an else if statement. And now at the end, we're going to have to take care of this overlap. And like I said, our overlap is going to be pretty easy. All we have to do is update our current interval at the start and at the end. And for the start, we're going to take the minimum between both intervals at the start. So interval at 0 and new interval at 0. So now our start is going to be the minimum between those two, and the end is going to be the same. But instead, we're going to take the max between the interval at the end and new interval at the end. So now our new interval is going to be our current interval and our new interval merged together, so there's no overlap. And like I said in the example, we don't want to add new interval to our result array just yet, because there could be more overlap in the future. So once this for loop is done, we can just add our new interval, because we're going to be short one interval, and we can just return our result array, and that should work. And here I made a typo, and now it should work. So as you can see, this code is pretty efficient, and now I'll go through the code manually. So I've drawn a new example here where our new interval is 3 and 5, and our intervals are mapped right here in the number line. So now let's start. So our result array is already initialized here in yellow, so that's done. And now we're going to iterate through every interval in our list. So we're going to start with 1 and 2. So now we check, is the new interval less than our current interval? So let's see, is the end of new interval less than the start of our current interval? No, because the end of our new interval is 5 and the start of our current interval is 1. So now we check this else if statement, and we check if new interval is greater than our current interval. So let's see, is the start of our new interval, 3, greater than the end of our current interval, which is 2? Well, that's true. So now we're just going to append our current interval to our result array. So now we go to our next interval, which is going to be 4 and 6. And we check, is new interval less than our current interval? No, because new interval at the end is 5, and that is not less than the start of our current interval. So now we check this next if statement. Is new interval greater than our current interval? No, because the start of our new interval is 3, and that is not greater than the end of this current interval. So that must mean they're overlapping, and that is true. And the way we take care of an overlap is by updating our new interval at the start and end. So the new start of our new interval is going to be the minimum between our current interval and our new interval starts. So the minimum between 3 and 4 is 3, so that stays the same. For now, our endpoint is going to be updated to the max between the end of our current interval and the end of our new interval. And as you can see, 5 and 6, the max between these would be 6. So now our new interval is going to be 3 and 6. And we don't add that to our result array because there could still be overlap for other intervals. So now we check our last interval here, 7 and 8. So let's see, is our new interval less than our current interval? Well, let's check. New interval at the end is 6, and interval at 0 is going to be 7. So this condition is true. So now we can append our new interval to our result array. So now we can add our 3 and 6. And now we update new interval to be this last interval we just went through, 7 and 8. So now we can just say new interval is 7 and 8. So now we're done going through every interval in our list here. So this for loop is done. And now we just append our new interval, which has been updated to 7 and 8. So our number line is going to include 7 and 8. And at the end, we just return our result array, which is this. This has the new interval merged together without any overlap. So this is correct. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.